function as a class-pair database hub. So in line with that, what we did, I just want to acknowledge my team members. And talking about the geographical extent of the work that we're trying to cover, we are trying to generate database, snow cover database for the state major river system and also the HKH basin. And what we are planning, what we are doing is trying to see with the database how the distribution of snow patterns varying along aspects, altitude and slope, and trying to see the trends, both the interannual, annual, and also seasonal trends. But here, since I have noticed that there are quite a few people that's following me talking on this aspect, distribution of snow cover in part of Himalaya, so my major focus would be on the methodology that we adopted rather than the analytical part. But I'll just skip through a few slides on the analysis. Regarding the data and sources, I would like to say that we did not work on the level 1B data or the reflectance data. Rather, we worked on the products that we downloaded from NSIDC server. And we mainly worked on using Modis 8-day product that we bought from NSIDC to cover all these 9 or 10 basins and the entire HKH Himalaya. We had to work with 24 tiles of 120 kilometers or 120 tiles of Modis 8-day product. For the topographical data, we worked with SRTM version 4, from where we could derive elevation data, aspect data, and slope data for our analysis. Regarding the boundary files, we stick to the files that we had in EC mode about the HKH file. And on the basin boundary, we used the SRTM 90-meter data to generate 10 major basins as well as 91 sub-basins. Methodology, you all know that discussion earlier was on the cloud, being much of the hindrance in mapping snow pixels. So first thing that we thought was to work on removing the presence of cloud or the influence of cloud in the product. And first thing that we did was combining of Terra and ECA. What we did in combining Terra and ECA is that if there is a pixel with cloud in any one of these product, and in the afternoon or morning we have another with snow, that in the product we combine it and replace with the information which contains contains snow or land, and that way we could manage to remove quite a bit of cloud from the product. And the other thing that we did was temporal filtering, where we took three sets of 8-day product, and we compared one set ahead and one set later following. And if there is a cloud in between, then we took either information from this cell and this cell and projected or reclassified into land. So we assigned a new code for the cross pixel to the land. And similarly, if there is a snow here and there is cloud here, there is cloud here, then we just took information from this and reclassified as a snow. So by doing this, we could quite significantly reclassify the cloud pixels and the product get to either land or snow pixel. The other thing that we adopted after doing those two steps was special filtering. What we also noticed in many of the products is that we had quite a bit of scattered cloud pixels and snow pixels. So we ran through all the images a 3x3 pixel filter and checked what are the major classes that exist in the 9 pixels, and depending on which classes exist, we reclassified the sample it as a cloud, and we classified into land or snow. Here we have this three as a major pixel as land. So we classified the sample cloud into land. If there had been a snow, then it would go into a snow pixel. In addition, misclassified, I would say, the snow pixels, which is obviously error in the estimation. So what we did in order to remove those low-lying scattered snow pixels was we tried to find from the references as well as with working with our data to find threshold value to off-limit those scattered, misclassified snow pixels in the low-lying. So we divided the entire HKH. We could not have come to one single threshold, so we divided those areas into 8 major zones and adopted some threshold figures based on the longitude and latitude of the entire section. And just for an example, and finally, to remove whatever cloud that exists in the product, what we did was we adopted the second level of temporal filtering, where we considered only if there are, for example, here we have a cloud pixel, and only if there are two same data, same information in the prior and the later image, then we translated this into that information from those two sets. For example, here we have this cloud, and only you have land here, translate into land. Here you have a cloud, we have a snow here, we have a cloud here, we still retain it as a cloud. This proved quite successful in removing most of the clouds in the product. And to talk about the sensitivity analysis or the success of this filter in removing the cloud, I just would like to show, I don't know if it is visible from the back, but I just plotted percentage snow cover on the y-axis and the time on the x-axis, and for every step you have Terra in the blue, the kind of cloud it has recorded, and echo the same in the data. And similarly, if you go other subsequent filter techniques like temporal, spatial, and temporal too, gradually you come down to a minimum amount of glass pixels that you have in the product. And that is for the cloud, and that is for the snow profile. As you remove the cloud, we saw that it was able to record more pixels at every step. You see Terra and Aqua down below, and as we go down, then the number of pixels that the process has recorded in the cloud has gone up in terms of percentage. Finally, talking about the accuracy, what we did was we did 2 levels of accuracy tests. One, absolute accuracy based on the in situ data. And for this in situ data, thanks to some colleagues in Beijing Normal University, we got station data from 168 stations here. And there it was contained snow depth and snow water equivalent. And using this data, we implemented error metrics in ADAS Imagine and try to see how good it matches. The result, I did for 5 levels of data sets, number of points and overall accuracy, and it was coming up. There is a wide variation of significant variation of overall accuracy in all the 5 steps. But there have been some studies done earlier, and most of these low accuracies are sometimes attributed the presence of snow, the very thin presence of snow. The other thing that we did was relative accuracy based on the high resolution snow product. What we did was, thanks to Anil Kulkarni, from where we had an access to even superior resolution product of part of Sikkim Himalaya. What we did, was we composite two images of 5D images and produce a composite 5D image from the UAVs to come closer to the 8J product of models. And we compared this data with our product, and overall accuracy was coming around 93%. And I feel we could do more on this and test on the accuracy further, since I have more database than I have got from Dr. Kulkarni. As of now, we have 8-day product from March 2000 to up to date for the entire HKH Himalaya, as well as for the 10 major basins. What we are trying to do for the wider dissemination is we are trying to implement a web-based portal through which people will have access to this kind of product. And we already have it, but we are in the testing phase and refining phase. By the end of this year, we would like to go out and open and give access to all the regional member countries and beyond for all the kind of data that we are doing. And we have all this analytical, functional graphs that you can create from here. And we also would like to give certain download facilities wherever required through our access portal. Preliminary analysis, it's not very conclusive as of now. There are still lots of work to do, but I just want to run through a few of this. There are certain, what I did is I plotted this time versus the total area of snow and just try to see how the average linear line goes. There are certain degree of variation. There are positive trends in few basins, negative trends in few basins. And this was a trend that average of the whole 10 years. And now I also disaggregated data into winter and summer and just saw how it varied. It is not yet very conclusive, but I would like to receive suggestions from you all how we could further work on this and refine this. Based on the elevation also, I tried to do this. I got a snow cover percentage I got a snow cover percentage for every 5 millimeter and saw in all the different 10 basins, and I tried to see how it features. This is also one of the, try to see how the elevation class relates to the percentage distribution of the snow cover. There are various differences in the, and this is the monthly variation for January to December for all the basins. In the interest of time, I just will try to skip it. This is based on the aspect for all these basins. I just try to see how. I just don't want to dwell on this because it's not very conclusive as of now. This I did for the slope. I want to go down to just want to say that cloud removal methods, even working with the products, has been very successful in terms of improving the quality of products. Of course, the ideal would be to work on the algorithm and come up with the snow-free product. But then, in terms of working with the products, these are the few things that we could do. This is just a basic. These are just a basic preliminary conclusion. Depletion rate in highest in the Brahma basin and accumulation highest in this basin. And there is a strong relationship between the elevation and the snow cover distribution. But lowest observed in Sarin basin. January, February, March, October, November, December indicate the maximum monthly variation in the snow cover area. In summer, the variation is much less. I think this is the final slide I have. Thank you so much.